So how does AutoScaler work with an ECS cluster? ECS is Amazon's Elastic Container Service. It is a container orchestration service similar to Kubernetes. It allows you to run applications and services using Docker containers. So let's say we have a web app. We have containerized it into a Docker container and published it to a container registry like ECR or Docker Hub. And now we want to deploy it using ECS. First, we have to define a task definition that contains the metadata about the container. Things like how much CPU and memory the container needs, and the registry location where the actual container can be pulled from. Then we need to provide a service definition, specifying things like the load balancer the service is published on, and the number of copies of the container or tasks ECS should run to support the service. Once we give the service definition to ECS, it will pull the container and make sure the specified number of tasks are running. You can even specify service AutoScaling, which will dynamically change the number of desired tasks based upon load factors like CPU. So as the usage of a service climbs, more tasks would automatically be added. Pretty darn cool. But there is one little catch we've glossed over here. All of these tasks have to actually be running on an EC2 instance somewhere. So behind the scenes, there's a set of EC2 instances in an ECS cluster called container instances that ECS will use to put the running tasks on. Eventually, as services auto-scale up, we're going to run out of room and may not be able to start any more tasks. This is where auto-scaling in ECS gets considerably more complicated. Not only do you need to configure auto-scaling on the individual services, you also need to configure auto-scaling on the EC2 container instance cluster. But this becomes tricky to do in a coordinated fashion, because the only thing you can scale against are the metrics of the running tasks. During a scale-out event, it often can take multiple scaling cycles to get all the desired tasks running. Containers start very fast, a few seconds typically. But starting EC2s is much slower, usually several minutes. Going through multiple cycles of starting EC2s can significantly limit the system's ability to scale quickly with load changes. So often systems end up being over-provisioned with extra spare capacity as a way to mitigate this issue. At reInvent 2017, AWS announced a new service to combat all this ECS auto-scaling complexity called Fargate. At the service level, you can specify between EC2 or Fargate. If you pick Fargate, it will assume the responsibility of finding the underlying compute infrastructure to run the container on, similar to how Lambda operates. Now we're back to our conceptual model of just worrying about service auto-scaling and the number of tasks we need. Very nice. Only catch is, Fargate is expensive. It varies depending upon the load characteristics of the services you're running, but for many workloads can often be twice or more expensive as compared to a well-configured EC2 instance-based cluster. This is where AutoScaler for ECS fits in. It is essentially a third-party alternative to Fargate at a fraction of the cost. Once enabled for your ECS cluster, AutoScaler will analyze the cluster to determine the total number and size of tasks required, including the desired ones that are not running yet, and compute the aggregate amount of CPU and memory required. From there, the most cost-effective set of instances to meet those requirements is determined, including dynamic instance type selection based upon the load being more CPU or memory intensive. Once the optimal cluster is determined, AutoScaler automatically drives the cluster to that state. This allows for much more responsive scaling up characteristics, which allows running safely at higher utilization, which also lowers operational cost. Even if you run the entire cluster on normal on-demand instances, the cost savings are considerable. But if you also give AutoScaler the option of putting a percentage of the cluster capacity in spot instances, the savings percentage grows dramatically. The speed at which containers start make it possible for AutoScaler to make working with spot instances completely transparent to an ECS application. This spot instance just received its 2-minute warning notice and is going to be terminated soon. AutoScaler detects this and tells ECS to put this instance into a draining state. ECS will start replacement tasks on other container instances to meet the service desired task count and terminate the tasks on this instance. Also, in parallel, AutoScaler will start spinning up a replacement instance. Because the container starts so fast, by the time the 2 minutes go by and the spot instance is actually terminated, there are no tasks running on it. And within another minute or so, the new instance has registered with ECS and the tasks will be rebalanced. All completely transparent to the application, but at a significantly lower cost. For more details on this topic, check out our blog post, Docker and Spot Instances, a match made in heaven. To see how to set up AutoScaler for an ECS cluster, watch the ECS config video.